In this presentation, we have to talk about reduction of a matrix to a diagonal form. Say a matrix is given to you, and the given matrix is a square matrix of order 3 by 3. So, for example, A equal to 1, 2, 3, 0, 1, 1, 2, 2, 2. This is a 3 by 3 square matrix. Then, with the help of this matrix, we can get eigenvalues. For this matrix, we can have 3 eigenvalues, lambda 1, lambda 2 and lambda 3, because the order of the matrix is 3 by 3, 3 rows and 3 columns. So we can get an equation in the cubic form. If you solve such equation, we can get 3 roots and are called the eigenvalues. Furthermore, using these 3 eigenvalues, we can have 3 eigenvectors x1, x2 and x3 for the given matrix A. With the help of these 3 eigenvectors, we can construct a new matrix x1, x2, x3. Then the newly constructed matrix may reduce the given square matrix into a diagonal matrix. Say this. A into B, B inverse equal to D. This is a thing we have to prove. Then the matrix B is called as model matrix, and the model matrix is constructed using the eigenvectors of the given matrix A. Using this model matrix, we can change the given matrix A into a diagonal matrix. Say that the D matrix is lambda 1, 0, 0, 0, lambda 2, 0, 0, 0, lambda 3. So this is the meaning of this theorem. Now read out this theorem. If a square matrix A of order n has n independent eigenvectors, then a matrix B can be found such that B inverse AB is a diagonal matrix. Now we have to prove this. Let A be a square matrix of order 3. Then the eigenvalues are lambda 1, lambda 2 and lambda 3. The corresponding eigenvectors are x1, capital X1, capital X2 and capital X3. Now, using these 3 eigenvectors, we have to construct a new matrix B. B equal to x1, x2, x3. Construct a new matrix B equal to x1, x2 x3. This is a new matrix. We know the eigenvalue equation A into x equal to lambda into x. The given matrix A is 3 by 3 . Therefore, we can have 3 eigenvalue equations. A into x1 equal to lambda 1 into x1, then A into x2 which is equal to lambda 2 into x2, A into x3 which is equal to lambda 3 into x3. Then what are the values of x1, x2 and x3? x1, x2 and x3. The value of x1 is equal to small x1, y1, z1. The value of x2 equal to small x2, then y2, z2. The value of x3 equal to x3, y3, z3. The matrix x1 is a column matrix with 3 elements, because if you consider the term A into x1, this is matrix multiplication. The matrix A is having order 3 by 3. So the multiplication matrix x1 should start with the 3 rows. That is a rule available in matrix multiplication. A is 3 by 3 in order. Now we have to multiply with x1. So x1 should start with 3 rows. Then only the multiplication is possible. 3 cancelled out. The order of x1 is 3 by 1. See here, it has 3 rows and only 1 column. It is a column matrix with 3 elements. In that way we have chosen x1. x1 equal to small x1, small y1, small z1. In the same manner, x2 equal to small x2, small y2, small z2. x3 equal to small x3, small y3, small z3. Now, the matrix B, the value of B equal to x1, x2, x3, which is equal to x1, x2, x3, y1, y2, y3, z1, z2, z3. This is the value of B. A is a matrix of order 3 by 3. Now find out the value of A into B. A into the value of B is x1, x2, x3, y1, y2, y3, z1, z2, z3, which is equal to A into capital X1, capital X2, capital X3. Because this is our x1, this is our x2, this is x3. So A into x1, x2, x3 is equal to ax1 comma ax2 comma ax3. Here the left hand side is AB. Now a into x1 equal to lambda 1 into x1 from the eigenvalue equations. From the eigenvalue equations, we can write AB, which is equal to a into x1 is lambda 1 into x1, comma a into x2 is lambda 2 into x2, then is lambda 3 into x3. Now substitute the values of capital X1, capital X2, capital X3. AB, which is equal to lambda 1 x1, lambda 1 y1, lambda 1 z1. This is the value of lambda 1 into x1 because x1 equal to x1, y1, z1. And lambda 2 into x2 is lambda 2 into x2, lambda 2 into y2, lambda 2 into z2. Here lambda 3 into x3, lambda 3 into y3, lambda 3 into z3. Now this should be changed into AB equal to, write down this matrix, lambda 1 x1, lambda 1 y1, lambda 1 z1, lambda 2 x2, lambda 2 y2, lambda 2 z2, lambda 3 x3, lambda 3 y3, lambda 3 z3, which is equal to the product of x1, x2, x3, y1, y2, y3, z1, z2, z3 into lambda 1 0 0 0 lambda 2 0 0 0 lambda 3. This single matrix is separated into two individual matrices. If you multiply these two matrices, we can get this matrix. See here, x1, x2, x3, y1, y2, y3, z1, z2, z3, lambda 1 0 0 0 lambda 2 0 0 0 lambda 3. Take this row and this column. In order to get the first element, x1 lambda 1 plus x2 0 plus x3 0. In order to get the second elements, take this row and consider the second column. To get the third element, take this row and take this third column. In this way, the multiplication is made. If you do the multiplication, you can get this same matrix. Then this is modified as, see here, AB, which is equal to, this is our B into, this is our D, diagonal matrix. See this, only the diagonal elements are present. This is D, this matrix is diagonal matrix D. Now multiply both sides of the above equation by B inverse. B inverse AB, which is equal to B inverse B into D. Here B inverse B inverse B, which is equal to I. I is 1 0 0 0 1 0 0 0 1. This is I. I into D, which is equal to D. If you multiply anything with I, you can get the same thing. I into D equal to D. Therefore, this equation can be modified as B inverse A into B, which is equal to I into D, because B inverse B equal to I into D. This is equal to D. Finally, we can write B inverse A into B, which is equal to D. The value of D is lambda 1 0 0 0 lambda 2 0 0 0 lambda 2. Now we can write the matrix B, which diagonalizes A, is called model matrix of A and is obtained by grouping the eigenvectors of A into a square matrix. See that statement, this gives the complete information about the theorem. A is a square matrix. Then find out the eigenvalues and eigenvectors. Using the eigenvectors, construct a new matrix. The newly constructed matrix can change the square matrix A into a diagonal matrix. That's the meaning of this theorem. Hence, we have proved the same.